So one thing you're going to have to do with molarity is just to calculate it. It's moles of solute per liter of solution, and I'm going to show you what this looks like. So I've got a volumetric flask here. Volumetric flasks only measure one volume per container. This is a 100 milliliter volumetric flask, and it's only got one line. So it's not graduated like a graduated cylinder. Like that. I want the molarity. I put 7.91 grams of sodium chloride in here, but I'm going to need to convert that to moles, and I'm going to make 100 milliliters of solution, which I'm going to need to convert to liters to get the molarity. So let's first do the conversion. Okay, so we have a number of moles of NaCl. I left 4 sig figs, and I'll round to 3 when I'm done, because I'm starting with 3 sig figs here, and we have 100 milliliters, which is 0.1 liters. So it's a 1.35 molar solution. So the calculation isn't too tough if you're calculating molarity. You have a formula, you go ahead and use it. You say, when you see this abbreviation, you say molar. It's 1.35 molar solution. So the kind of thing to really remember here is that this in the denominator is liters of solution. This is not saying that I'm adding 100 milliliters of water. I am adding water until I hit this line. That means the salt is taking up some of the space, and the water is taking up some of the space. So I'm going to be adding a little bit less than 100 milliliters, and I don't know exactly how much I'm adding. I just know I am filling to a line. So that's something to note there. Use a volumetric flask, you'll fill it up most of the way. Try to mix it. I can't find my cap. When you want to really mix these, you need to invert it. If you invert it 3 times and mix, that'll work. I just don't have a stopper here right now, so I'm just mixing here. But I want to point out you got to go really slow when you get close to that line, so you don't want to be pouring out of a carboy. And then you might even want to get a pipette. It's a really important solution like this one is, because when it goes down the drain, I need to know that it's 1.35 molar. Yeah. Now that needs to be mixed, but it's pretty. I'd probably add another drop, but I got to mix that and make sure that it only goes to that line. If you go past the line, what happens? You start again. You just ruined your solution. It's not 1.35 molar. Anyway, so there's a 1.35 molar. The main thing for molarity, you are filling to the line.